the fertile ground where SMEs can really take the advantage and grow if they have the availability of data. You have seen outside the UAV that we have used in the AgroLES project, the one that carries 2 cameras, simultaneous thermal and multispectra. You will see the result later on, but now we will have a distinct calling, and a friend of mine, the president of the Remote Sensing Society of Cyprus. By the way, I just got, Kyriakos, the call that on April we are going to be meeting again in Cyprus, and he is running the Cypriot brother of IBEC, which is the IMEC, who just created in Cyprus, and he's going to tell us about the current situation and the trends in UAVs for agricultural purposes. Kyriakos.
Okay. I would like to thank George for inviting me here today. Today I'm going to talk a little bit about UAVs. And whenever we're talking about UAVs, and most of you probably saw a UAV, and a UAV is more a military term, but most of you, they know the terms of drones, aeroplanes, and probably we have seen little kids now playing with them. So this is a technology that it was introduced probably 4 or 5 years ago in the commercial use, and we see this technology growing up every day. We talk about satellites. We talk about aeroplanes or UAVs. We're talking about low-altitude airborne systems, balloons, or the UAVs, the drones that we're talking about. And we just saw about soil spectroscopy, and we saw how to collect information from the field. Just mark one word: integration of technologies. This is the most important thing that we will see here today together, how we can integrate technologies in order to gather information. This is the second word: integration and information. This is the most important thing that we want to see, we want to gather, we want to do an Earth observation by collecting information by any means, either that has to do with satellite, that has to do with aeroplanes, that has to do with drones, or that has to do with field spectroscopy. So we have different types of UAVs, and here you can see some of them that we have in our lab. You probably heard about quadcopters, and this is with 4 copters that they're running. We probably heard the terminology hexacopters with 6, and octocopters. And we probably heard about little airplanes, sliders or model airplanes, and we probably see helium balloons that most of us we are using in meteorology, collecting meteorology data. What's the difference between them? And a lot of people are asking me, what's the best? I want to buy a UAV. What should I buy? And what I say, a UAV is a tool. What you want first is what kind of information you want to collect. If you require heavy sensors, then you have to go and buy something bigger, maybe an octocopter or hexacopter. If you want to collect information with lighter sensors, then you can get a really inexpensive quadcopter in order to collect that kind of information. And when we're talking about information, it might be information that has to do with imaging, or information that has to do with monitoring health, crop health, or see how we can increase the yields in the fields. Here you can see some of the pictures that and information that we trying to gather from the field in order to determine the health of vegetation and help the agriculture sector increase the yield in the field. Whenever we want to gather more information, we rely on sliders. Sliders are small aircraft, small airplanes that we fly. They're more like model airplanes that we can put sensors on them. Usually we put thermal cameras, we put infrared cameras, we put visible cameras, and from there we can produce NDVI indices that we can monitor the health or the stress of the vegetation. There's a lot of technology that came out when we started using UAVs in order to collect NDVI. We actually got into the point of collecting information, and that information led us to other type of research. For example, we started to see archaeological artifacts or the croc marks that they started appearing using NDVI. We start seeing even, and that was a couple of weeks ago, we flew over an area that we started to see military installations, underground military installations. So NDVI, and whenever we're talking the stress of vegetation, whenever you plant vegetation, the vegetation is stressing for different reasons. And that is the information we're looking, why the vegetation is stressed. Is it sick? Is it something that is causing it to stress? Or is it something that there is over there that we don't know about? So this is the type of information that we want to gather and we want to process. Here I'm showing another slide. Now with the drones, we're able to fly those drones within the vegetation. And now we're trying, we can create leaf area indexes. We can recreate the whole plant in a volume. We can see how the plant is growing. We can calculate the height of the plants. We can calculate the volume of the plants. And we can even see the health of the plant in a much more higher resolution that we can see from a satellite or any other sensors. Here, that's another copter that we created, another drone, that we put a spectroradiometer on the drone itself. So this is an Ocean Optics. It's a small sensor that we were able to attach there and get spectroradiometric measurements that we could analyze and see not only the health, but see the chlorophyll, how the chlorophyll is existing on a certain plant, and even calculate different type of indices using this type of technologies. Here is another quadcopter, and this is kind of interesting, new technologies. Every time that we build a drone, by 3 years down the road is an old technology. So we started building drones every 3 months, and we started using new technology. What we had last year is an old technology now. So if you get into the business of the drones, you have to be ready to always integrate them to new technologies. You know, it's a new technology, it's rapidly expanded. We see new developments every day. Now we see even more stable UAVs or new stable drones, and we're trying to experiment always. And not only that, just remember one thing, drones are tools. They're not solving the problem themselves. What we want is information. Yeah, the sensors that we're using and the type of sensors we can feed on these drones are the most important. Now, what is leading us? What is the future of UAVs? We see, as we go, smaller sizes of drones that they come into surface. And I'm a visionary. I can imagine in probably 5 years from now, if we're still in this room and we still have lectures about Earth observation, and I'm pretty sure we will, we probably won't have a person taking pictures with us. We probably have drones with the size of flies flying around us and recording the whole conference over here and taking pictures of us. And not only that, but gather information about us. We try to see longer battery times. We are struggling with the battery life. And this is because now with the drones, we can fly them for half an hour, maybe most of it 1 hour, but we have limitations of battery life. We see new technologies that are coming out. We probably in a few years from now will be able to have a drone up there for hours and hours. We just saw the HAPS system that we can fly these for hundreds of hours and we still can get life out of it. Flying longer flight paths. That's another thing that we are hoping to do because now with the drones we're limited where we fly them, how far we can fly them. Usually now we can fly them safely in a couple of square kilometers. We have restrictions of the height that we fly them. A lot of the governments, they won't even allow us to fly them more than 400 meters in height. Increase of accuracy, and we see that every day. Higher resolution of images. In our lab, we managed to get a resolution on 1 or 2 centimeters of resolutions right now, image resolution right now. In the future, this resolution is going to drop to millimeters. And we are hoping now with the new sensors, new technology that we see that is coming up and lower cost. A lot of people are asking me how much of these are costing. These are costing depending on what kind of UAV you're building for what kind of sensors. Usually sensors are more expensive than the drones themselves. We have sensors, usually thermal or hyperspectral sensors, that they're running on the hundreds of thousands. And we have UAVs as low as 1,000 euros. So we're not talking about the cost of the UAV, but the cost of the system, the integrated system that we are building. And of course, greater safety. Safety is one of the issues that a lot of the governments are struggling right now. What's safe and how we can fly these things, where we can fly these things, and are they safe to fly? And of course, larger payload. We need a larger payload because we need more sensors, we need more information on these things. Well, technology, we're not far away from technology. We're looking right now of having actually drones that are in the size of a mosquito, and this is a technology that is been going right now. We've seen sensors that they fit on the tip of our thumb, UAVs that they fit on the tip of our thumb, and we're not far away. This is a drone that is developed by the US military. It's the Black Hornet Nano, and it's launched and compound in Afghanistan and Iraq. And this is an actual picture. You can fly these drones and you can actually get images for a couple of kilometers. And soldiers are using this in order to save lives. So again, gathering information. So I'm going to leave you with two words: integration of technologies and information. Thank you very much.
Thank you very much, for your presentation. And now, since we went all the way from the sky to the space, now we have to land on the ground. And we have together with us Bernard Posser. He's the CEO of Atcom Company, and he's going to tell us all his experience about ground sensing, in situ sensing, and what that means for agriculture. Bernard, thank you very much. The floor is yours.
Thank you, George. No presentation. You just have to listen. I'm going to tell you a story. I'm actually a lawyer by education. I have no idea, I had no idea about agriculture, precision farming whatsoever, and I happen to know the owners of the company I've been working for now for 15 years. I ran into this guy in 1999, and he said, Bernard, we need a new sales guy. We want to go public, and somebody has to run sales. I'll show you what we do, because I know you're a lawyer, you're in computers, you don't believe in agriculture. I'll tell you everything about AdCon. He gave me a presentation on weather stations, disease models, telemetry, soil sensors, and I thought, wow, this is great. This is going to sell like hotcake. For once in my life, I'm going to do something useful. I sign on with these people. And I started talking to farmers. And they went like, so? A lawyer telling me, a farmer who grew up on a farm, kid of a farm, who has agriculture in his genes, how to run my farm? Not going to happen. So everybody believes what we're talking about, but farmers. And you now try to think, why is that? Why does everybody understand how weather stations, sensors, disease models, irrigation models could improve the life of farmers, increase food security, whatsoever, but farmers? Now you need to think back, how are farmers being educated? And that is, from my perspective, a very sad story, because in those last 16 years, since 1999, internationally, I have not seen any change in the way farmers are being educated. So I was really delighted when in one of the welcome speeches, I think it was the vice governor, he mentioned that you're going to invest a lot in the training of farmers to understand what is IBEC actually doing here. What is this combination of soil data, ground data, aerial data going to do for them to make them understand a bit more of this atmospheric, soil, water continuum, plant continuum? How do all these things interact? That is absolutely fundamental. What we are talking about here is not a black box. Unfortunately, most farmers who invest in technology, they think they're going to buy a black box which is going to solve their problems. Switch it on, and it's going to tell me what to do and when to do it. And also, that ain't going to happen. If you think about investing in situ monitoring, building a ground observation network, you need to know exactly what you're doing, for which purpose you need that, what you want to achieve. And George mentioned that before. Too many times these stations are being installed in absolutely inadequate places. And that starts when you talk to a farmer and you say, you do weather stations. The first question you get is, how many days can you forecast with that thing? The answer is simple, 0. You can't forecast with a weather station. You want weather forecast? You need a radar image, you need satellite observation, you need lots of other weather stations. Data integration, this all comes together. A single weather station is not going to solve a single problem. Second question you get is, how many hectares does my new weather station cover? Answer gets more complicated. That depends. You have to think in microclimates. If you are in the hills in the north of Greece, one weather station in viticulture maybe is covering 5 hectares, maybe 10. If you go to Iowa, if you go to the Midwest, one weather station might be covering 10,000 square kilometers. Flat, corn, no mountains, no rivers, no lakes, nothing but corn. Greece is very different. So again, you need to understand, what are you doing here? And then the question comes now, where exactly do I put that thing? We were at a very fancy restaurant yesterday night from a quite prestigious Greek farmer who makes excellent wine. And of course, the man has a weather station because wine is a costly product. So you want to improve what you're doing. And that weather station was sitting right on the porch of that farm. Now, from an agriculture perspective, the porch of that location might not be well chosen to tell me what is the temperature, what is the moisture within his canopy, within his crop. So you need to think about, what is the criteria for installation? Is that safety and convenience, or is that my crop? If it's my crop, which crop is it? Single crop, multi-crop, single purpose, like disease modeling, multi-purpose, irrigation, flood warning, other things. So the IBEC initiative, which unfortunately has to take care, or fortunately I should say, has to take care of lots and lots of crop. They have the difficulty to find the ideal location for all the equipment they're putting out to cover as many applications as possible, finding a good compromise between irrigation and disease. collect all this information in a central location, start providing not only the raw data, because raw data per se means nothing. If I tell you as a farmer your crop is now 23.58 degrees, so what? What a farmer wants to know is the conversion of raw data into information he can act on. Either this farmer learns himself what he can do with that data, how he can work with a disease model, with an irrigation model, but that would require him to study fairly comprehensively the underlying algorithms behind this disease model. And now that's where the sharing of data comes in. You want to start stimulating third parties, SMEs, crop consultants, to grab that data, feed this into specific disease models, be they American, be they German, hopefully very soon be they Greek, and adjust that model to your local conditions in terms of crop and soil and practice and your disease developments, and then tell the farmer what to do, when to spray, what to spray, how to irrigate, how much to irrigate. Why this is so important is now more than ever, because of a new EC directive, it's called the Pesticide Directive, number 128 from 2009, which I personally thought is going to boost our business a lot, because all of a sudden there is a European law saying all European member states have to implement this new directive in order to reduce the application of pesticides, all based on integrated plant management principles. So what have they done? They have all created a new law, which has basically said, the way we've been doing this until now is really cool, it's really good. We actually don't need to do anything because we're good. And I like the names they have all given to these plans, the so-called national action plans. And when they found the abbreviation for these plans, they didn't understand the underlying humor in that name, NAP. They are still napping with their national action plans as nothing is happening. So an initiative like IBAC, where a combination of public, private, non-governmental organizations is now taking this into their own hands and saying what we need is to finally implement, and I've heard that word this morning, the state of the art. We need to bring the agricultural, and I like that, everybody says the agricultural industry to the state of the art. Imagine you want to open a power plant somewhere. You're going to be pestered for years and years with environmental impact studies. You will have to prove that you're using the latest in technology for filtration and keeping the environment clean. But if you're a farmer and you run a 200-hectare farm and you decide to spray today and tomorrow and the day after tomorrow and on the weekend, you can spray all you want. Unless you kill somebody and that guy can prove, or actually the people left behind can prove that your chemical sprays was what killed that guy, you can do whatever you want. You can waste all the water you can get. You can make all the mistakes that you want. And that is something that has to come to an end. And therefore, the combination of getting as much data as possible, convert that data into useful information, start training farmers to understand what's going on is something which I feel absolutely thrilled about when I heard about this IBAC thing and initiative, which I really appreciate a lot, because unfortunately, believe it or not, there aren't many initiatives like that in Europe. It's the first and only thing which is covering a number of countries from the understanding that you share, we've heard this before, we don't have borders, so you share the same environmental problems. A disease that is developing in one country is going to inevitably hop across the borders. Tell your neighbors, share your data. I tried this in '99 with the Austrian government and the Slovenian government and the Croatian government. They had all purchased our stations, they had all the same data, the same database, the same disease models, and they had all the same problem. It was called Erwinia amylophora, a nice little bug, a bacteria, that was killing apple orchards in Europe galore, like big time. And the only thing you can do against Erwinia amylophora is either you cut down your trees and burn them, or you spray an antibiotic. But to spray this antibiotic, you need to hit the outbreak spot on the day. You need to run a disease model that tells you exactly, now I have ideal conditions for a vineyard to develop, spray now. Now the Croatians every year, and it first occurred around 1996, the Croatians always had this problem first. And as summer proceeded towards the north, it jumped into Slovenia, it crossed Slovenia, it jumped into Styria in Austria, it went all the way up to Germany. So one might think it would be a good idea to share this Croatian development data with the Slovenians and then with the Austrians to give us some pre-warning time. Well, it was a good idea, but it stopped right there. Because it's our data, you know, it's our national data. This is so secret, we can't share that. So what did farmers do? They started to call friends on the other side of the border. So, got something, got some traces? Is it happening or is it not happening? So farmers, luckily enough, started to understand that they need to work together, and not just in the same village or the same province, but in different countries. And that George manages to get countries together which potentially politically are not always on that same agenda, sharing the same vision, is again something I like a lot, because it shows that sometimes on a practical level, people are willing to give up national, chauvinist, whatsoever attitudes which their politicians might not approve too much of, but here, to further the case, this is really needed. So from my perspective, to wrap things up, I like what they're doing. I wish this initiative a long life and a long future. We'll stand behind to improve the education that you're providing to farmers, to give them as much understanding as possible on, as I said, instrumentation, disease modeling, irrigation modeling. And if anybody of you has any questions afterwards, I'll be around. Thank you, George.
Well, it was really an inspiring talk about sharing data and seeing limitations and constraints that we have to cope about. And because Bernard mentioned how important it is to work with people across boundaries, we have on Skype, I think, Christo, is he on Skype? He locked off? Okay. I would like, before I try to really close up, we're running out of time anyway, to hear any comments that anybody who wants to really follow up in the discussion that we have proceeded. Matthew or Carls or anybody from the panel that would like to come back. Is Christo in? If he's in. Christo, if you hear us? Hello? Seems
Hello,
like...
can you hear me?
Yeah?
I'm sorry.
Okay, Christo, the floor is yours.
I was following. Thank you. Thank you for allowing me for having this opportunity to join the conference remotely. Unfortunately, the situation in my country is not allowing me to join you, but what I would like to share is to really value the works I have heard up to now, especially being from research side. I highly appreciate the presentation made by Eyal Bendel, because he provided a really nice view about how we can create a top database in soil sciences. From another point of view, I really appreciate the last word from Bernard, and I see what we miss here in our country, and especially this exchange of any information that can be useful for our neighbors in a smaller or perhaps larger region. And what I guess that the IBEC initiative could be shared in Bulgaria. And here I would like to use this event to invite Professor Zalidis at any time here in Sofia, so we can organize an event here, and especially sharing the ideas about the IBEC initiative in sharing data about Earth observation and modeling of the environment. And also, I would like to share the views about the GEOS initiative in Bulgaria, because we are just starting some very, very first steps in that direction. What I'm happy to share here that next week, I suppose on Thursday, there will be a special lecture dedicated to GEOS activities, unfortunately not in environmental science, but in using GNSS services. But nevertheless, the message about GEO initiative should be spread as much as possible.
Okay, Christo. Okay.
Of course, I will stop here. Unfortunately, I'm prepared for something like a round table and ideas shared, not having the presentation in front of me. I'm sorry about this.
That's okay. The most important thing is to keep working together, and you know that we are going to be having the chance in both Horizon geo capacity building in the area. We are going to be working together, and hopefully in the new ESA project that we are working together in trying to really build capacity in really take advantage of HAPS platforms and other satellite data. So we'll keep working together, and since now the region of Karjali, which we have the regional governor here, is part of the new EGTC created, then we'll have the opportunity to really keep working much closer. Thank you very much, all of you.
Okay,
yeah, go ahead.
For now, for me, and I will stay online watching the live video streaming of the conference.
Okay, thank you very much.
For providing me this excellent opportunity.
Any other comments from the panel in terms of closing? Yeah, you push the microphone.
You know, the problem with lawyers is once they start talking, they're hard to stop. So the question is, how much time do you give me?
Well, we don't have a couple of minutes intervention you can make.
Good. There is one more paradox I didn't talk about, and that it becomes crucial when you start introducing private sector initiatives like crop consulting. Most European countries have organizations that force farmers to become members of these organizations. There are the so-called chambers of agriculture. They're all connected to the Ministry of Agriculture. And all these organizations, by their statutes, they have to supply farmers with information on cropping, seed selection, disease modeling, irrigation, free of charge. Because the farmer pays for these services, this membership anyway. It is almost impossible in these countries that you can create a private sector of disease consultants or crop consultants. So with an initiative like IBEC, where they really want to stimulate the private sector to go into all these areas, they need to make sure that in parallel the government is not messing this up. And the prime example how well this works if government here does not interfere actually is the US. Go into California, go to Napa Valley, Mendocino County, Sonoma County, and ask any of those prestigious, well-known grape farmers, Kendall Jackson, Gallo, Fetzer, whatsoever, how they treat their crops. All of these guys work with private consultants, all of them. The more expensive the guy is, the better he must be, because he's expensive. Over here in Europe, that is unthinkable. Now let's go back to the guy we visited yesterday. The man runs a grape farm, and potentially, if he's doing a good job, He has a revenue per hectare of 40,000, 50,000 euros. Now he has 100 hectares, we're talking €500,000. So he makes a mistake that costs him 10%, that's 50,000 euros. I think that man should be willing and understanding that a good consultant who costs him a few thousand euros can not only help him avoid these mistakes, he could help him get actually 10% on top of what he already is getting. So if the IBEG initiative stimulates that, I see tremendous growth potential in output, both in terms of quality and in terms of quantity, for Greece to finally get back on track to become a leading export nation for agricultural products. There is so much great stuff growing in Greece that could be sold really well into most European countries if provided in sufficient quantity. It's not just domestic markets that's interesting for that initiative, it's export. And therefore, I really wish you well in succeeding to stimulate private sector growth to work with the data you're generating, George. Thanks.
Well, that was very inspiring, and we hope, because this is our ultimate goal. Concluding, I would like to say that we saw the future of satellites, the futures, we have new satellites coming out. Eyal didn't talk about the Salom mission, we have the Venus mission, we have the new Sentinel, we have the InMap, which will take off in a few years also, and we have all these Copernicus services that are really feeding us with data. The ultimate question is, are these data right now able to do ecosystem services, and especially agro-ecosystem services in terms of providing farmers accurate management information? This is something that we have tried it, and you will see it in the next session that has happened. The mission here is to work at a river-level basing across all ecosystems, following the Nexus approach that is combining soil, water, energy, and food security together in order to really have the farming industry succeeded. The important message that all of you said, and it came across, work across all ecosystems, works across all platforms, across all levels of sensors. It's very important to be able to combine different complementary sensors and use the principles that Barbara mentioned at the beginning of establishing GeoSSS. And this was what we have done with a previous project that we just added through the digital convergence here in Greece. We were able to establish a common geo portal based on Earth observation data using Internet of Things for agriculture with 5 decentralized administration of Greece. And we developed the national system of systems that is available to the Ministry of Agriculture to be used and be really populated. And we hope that the services that have been already up and running in terms of agricultural applications for irrigation, fertilization, and plant protections, early warning and decision-making of management of natural resources. Of course, this includes flood warnings. That's very important in terms of really being able to prevent catastrophe in agriculture. And the first agricultural social media network that is up and running and hopefully will be populated very soon. What are the benefits? The benefits are to the state, to the citizen, and to the business. Services at the informative level, at the communicative level, at the interactive level, and for the first time, because the digital convergence was only for the civil service, it's at the managerial level we are providing services. There is a continuous supervision and management of services at the control room by IBEC, and of course there is a sustainability because we have and we are creating this ecosystem that Barbara has shown you. Of course, what we learned from Barbara is to think global but act regional, and what we are doing here. And you are going to see after the break how some of these principles were implemented in the agroless project, which was the first attempt to develop and populate agri-earth observation data in Balkans, and especially in Greece and Bulgaria, and we're happy to have Bulgarians first here, disseminate, implementing the reduced input protocol, and we have discussed with the General Secretary how important it is to really have in the country this reduced input protocol, because it's very important for the farmers to have the benefit of that and have their products marked and traded with the certification that have been produced at the reduced input supply, and that's going to give an extra added value. So having said that, I would like to have a coffee because I think we prolonged it much longer, and we are going to proceed with the next part. Thank you very much.